There, we got the right presentation now. So my name is Jesse Ezell, and I run an AI startup called Timu, and I help people build AI agents of all kinds, chat bots, voice bots, computer-used bots. But today, we're going to talk about voice agents. Specifically, we're going to talk about building voice agents with Flutter, LiveKit, and things like WebRTC. So one of the first questions is, why might you want to consider Flutter if you are building voice agents? And one of the reasons that Flutter is a really compelling option for building voice agents is because you have a single platform that you can ship voice agents with, whether you're shipping voice agents on web, whether you're shipping voice agents on mobile, or whether you're shipping voice agents on desktop. And so this is rather unique about Flutter, something that's very hard to do with another solution. One of the great things about Flutter as well is it has great supports for WebSockets, and more importantly, it has great support for WebRTC. And we'll get into a little bit why, if you are building voice agents, you really need to be building on top of WebRTC. That's not where everyone starts, but that's almost always where everyone ends up. So there's also some reasons that you're not going to be able to use Flutter, and so let's cover those a little bit. Now, one of the things is that Flutter is great on the client side, but unfortunately, the reality of building voice agents is that you're typically looking at a server deployment. And while Dart and Flutter are great for user interface, the stack for voice agents on the server side really doesn't exist when it comes to Dart. So unless you want to build that stack yourself, it's likely that you're looking at something like Python on the back end. Shouldn't be too surprising, because virtually all AI projects at some point are going to touch Python. Now, one of the other things is that Dart itself doesn't really have a good audio stack. So Flutter is notoriously difficult when you want to do things like playback streaming audio without clicks. And this has been a persistent problem for everyone using Flutter for a long time. But the nice thing is, if you use the WebRTC stack, this is not an issue you'll have to deal with yourself. Now, you really could roll your own voice agent Flutter or voice agent stack for Dart, but because one doesn't exist at the moment, I would recommend that you end up using Python on the server for your voice agent. You could also go with JavaScript, but again, the reality of the state of AI these days is Python is really going to be your go-to. And if you go with something like a JavaScript SDK, likely you're going to be giving up functionality. So let's talk about building your first voice agent. Often when people get started using voice agents, they realize that at a high level, a voice agent is relatively simple. What you need to do is you need to take your audio data, your raw audio data, you need to pass it to a speech-to-text model. That speech-to-text model is going to give you text that represents what the user said. Now, the next step is you're going to pass that text to an LLM. And so in some ways, it looks similar to a chatbot. And then when the LLM responds, you're going to take the text that the LLM gives you back, and you're going to send it to a speech-to-text model. At a high level, this is how it works. And so a lot of people, when they first get into voice agents, and you can even see this if you look at, say, the OpenAI's Agent SDK. What they'll do is they'll take their mic and they'll stream these packets straight through to the text-to-speech provider. And maybe if they're thinking about a server, they might stream those packets over a WebSocket to the server. Now, there are a lot of providers out there that will give you things like streaming transcription, that will do things like stream back the audio data so that you can stream it to your users. But the problem is that you're dealing with PCM data. You're not dealing with compressed data. And while this might work in a demo, it might work great on your local machine over localhost, it will never work in production because it requires far too much bandwidth to go over the wire, especially when you're dealing with things like mobile phones. So the problem really comes up, what happens when you're not on localhost? What happens when your internet connection is not so great? Maybe you're on a mobile phone and you don't have full reception. The problem is that on a mobile phone, your bit rate can drop relatively quickly and it can drop drastically. And so if you built a solution on top of something like WebSockets sending the PCM data, and then the user goes into an area with poor coverage, what will happen is the audio will stop and it will buffer, potentially for a very long time. And you don't really have, with WebSockets, a good way to do flow control. So you potentially don't even know that those packets aren't making it to the user. And another problem is that when you look at the wide variety of speech-to-text and text-to-speech providers out there, a lot of them only deal with uncompressed raw PCM data. And they're not dealing with encoded data, which makes the problem even worse because it's not like you're sending a compressed audio stream over the wire. You're sending raw audio data that could be 10 times larger. Now, so if you're using WebSockets, what's going to happen is the data is going to get buffered, the audio is just going to stop, and the user is going to have to wait, potentially perpetually, to hear the next part of the audio. So this is why, at the end of the day, people end up using WebRTC. Because the nice thing about WebRTC is it does have built-in flow control. It does have the built-in ability to automatically adapt the stream to the user's bit rate. WebRTC also has built-in audio compression, so you don't have to worry about manually doing audio compression on your stream. And another fact about WebRTC that's really nice is often when you're dealing with these kind of systems, you can have problems due to connection issues, and WebRTC has a great way to work around common connection issues that you might have with NAT using stun and turn. So the next problem you're going to have when you build your voice agent is that at some point you're going to want the voice agent to stop talking. So often when people first start doing voice agents, they might think, well, I could do push to talk. I can talk, I'll push a button while I'm talking, and then when I release the button, I'll send those packets over to the model and I'll get a transcription. But that's not very natural and doesn't work when you're hands-free. And so what you really want to do is have the conversation be natural, which requires you to have some type of automatic detection of when the user is done speaking. Now this is typically called voice activity detection. When you first start building voice agents, you might think that it's just as simple as doing something like listening to the volume levels on the data that's coming in. But the problem is, if you're just dealing with the raw audio levels, it's hard to distinguish between, say, a loud noise in the background, maybe a user typing on their keyboard, and actual voice audio. And so what you end up doing in this process is you need something that's more sophisticated. What that's generally called is voice activity detection. The way voice activity detection works is you take a lightweight model, something that's typically small enough that you can run it on a single CPU. You pass the audio data to the voice activity detection model, and it's been trained to tell you when the user is no longer speaking. Now, these voice activity detection models are pretty state of the art. A lot of them are still under R&D, but they're a lot better at detecting when users are done talking than trying to do something like just look at the audio levels. So you hook up your voice activity detection, and your next problem is going to be if the user does start talking and it does interrupt the agent, when did it do it? So what you'll do is you'll send a sentence to ChatGPT, to something like OpenAI, it will give you a sentence back. So you start playing that audio back to the user. The problem is, somewhere midway through the sentence, the user cuts off the agent. Now, the user might say something like, "Can you please explain that to me?" Now, unless you know exactly where the agent was stopped, you can't give a proper response to the user. You can't assume that all the audio that you generated was actually transmitted to the user, because in this case it was interrupted, so obviously it wasn't all sent. Now, the best thing you can really do here, there is a problem. The current set of speech-to-text and text-to-speech models are generally pretty bad about word timings. Now, when you give a sentence from ChatGPT to your text-to-speech model, you don't provide timings on the words. You don't say this word is at 1 second, this word is at 2 seconds. And the other problem is that when the model gives the audio back to you, it doesn't give you word timings. It just gives you raw audio data. So you have a very real problem that you don't exactly know where the user cut people off. Now, maybe at some point the models will get better. Hopefully they will. But at the moment, generally what you're going to have to do is estimate a rate of speech and estimate where the user cut off the agent. Now, that estimation is not always going to be that accurate. So generally, this is one of the reasons why you may want to give your voice agents system rules to make sure that they don't ramble on forever. The longer that the agent talks, the harder it is to guess where the user stopped the agent. Now, what about background noise? There is a very real problem with voice agents today. And voice agents are not good at dealing with background noise. It doesn't matter if you're using the best model from the greatest company, your voice agent is not going to deal well with background noise. Now, the nice thing about WebRTC is WebRTC does have some basic echo cancellation built in. So that's going to be a lot better than just listening to the mic. But the problem is that none of the current voice activity models are good at dealing with background noise. Now, in practice, that may or may not be an issue for you. The reality of voice agents today is you can only use them in a quiet room. You can't use them in public. The reality of voice agents today is that when you're demoing them, this is something we see often, you typically have to mute your mic, or what ends up happening is you'll be giving a demo, you'll ask the agent a question, the people you're demoing to might say, "Wow, that's amazing," and all of a sudden the agent stops talking and thinks it was talking to them. You'll also have issues like the fact that outside of a very few handful of new speech-to-text models, the speech-to-text models are not very good at identifying the speaker. So even if it's not background noise, it might just be another user. Let's say you have a voice agent that can access someone's bank account. The voice agent can't tell who's talking to it. So it's easy for another user to ask it a question, and it can't distinguish between the two. So one of the things that I think is important to talk about with voice agents is that not everything is good for voice. When we first started building voice agents, we thought they were amazing. We thought this was the future, and every interaction that everyone is ever going to want to do with AI is going to be voice. It's so much cooler. But it turns out that the phrase, "a picture is worth 1,000 words," is really true. There are many cases where voice is not good. A simple example would be a code snippet. A code snippet is relatively hard to describe with text. You don't want to say something like curly brace, parenthesis. It would be really, really verbose. The only way to really get a code snippet across is to show the code snippet. So I think one of the things that you need to keep in mind with voice agents is it's very likely at some point that you're going to need more than voice. You're also going to need something like text. you're also going to need something like images. You need to keep open the fact that your agents need to be multimodal. Voice alone is not enough. So one of the issues that comes up is, I think earlier, if you were in this room, there was a demo of Project Astra. And in the demo, they showed a voice agent where they could give camera access to the voice agent, and the voice agent could see what was happening on the other end. Now, there's a lot of scenarios where this makes a lot of sense. For example, in the Project Astra video, they showed, I'm going to show a picture of my bike, and I want the agent to explain to me via voice how to fix it. Now, another great thing about WebRTC is not a protocol only for audio. WebRTC is also a protocol for video. So you can also take video and send it to the model so that the agent can not only hear, but see. The other great thing about WebRTC, when it does this, it compresses. Now, the models typically can't handle the full frame rate of a video, so typically what you'll see people doing is every few seconds send a video frame over to the agent. Most models these days are multimodal and can deal with text data directly. Ultimately, I think the thing to understand is you are in control of the context window. You are in control of the agent. So if you need to provide more than just audio data, whether that's text messages from the user or whether that's video frames from the user, you can add those to the context window and use them. So what about calls from phones? Usually when you start building voice agents, you're doing it on your computer. But the reality of voice agents, if you look at all the voice agent deployments today, they're not things like Project Astra. Maybe in the future that's how it's going to be. But the long tail, where voice agents are useful and where voice agents are being deployed today, around 80% of voice agent deployments are actually voice agent deployments that are connected to phones. Now, phones have all sorts of problems. The audio quality is really bad, and you can't do multimodal interactions with phones. But most businesses in the world today already have phone systems. And so if you want to build a system that can communicate with the systems that are already in place, things like call centers, voice agents tend to be a go-to. There's already a lot of call centers that have voice automation or systems where you dial numbers on the keypads, so voice agents end up being a natural fit. One of the great things about using WebRTC is that most WebRTC stacks have the ability to connect to a SIP trunk. So if you start building on WebRTC and you end up wanting to have your agent be able to dial out to a user or have users dial in and connect it to something like a call center, you're already set down the right path if you're using WebRTC. So deployment. One of the interesting things about voice agents, and I think about agents in general, is that they change the paradigm of the way that software is built. And for many, many years, we've been taught that systems should be stateless and that requests should be short-lived. If you look at a lot of the serverless stacks today, you look at things like AWS Lambda, or you look at things like Google Cloud Functions, that's what they're designed for. And so your first instinct when you go to build a voice agent might be, well, I'm just going to deploy it in a Google Cloud Function, or I'm going to deploy it in AWS Lambda. But it turns out you can't, because voice agents are not stateless, and they are long-running. And so typically, these serverless platforms tend to have very short timeouts, things like 30 minutes, 45 minutes, maybe an hour. But what happens if your customer support call lasts 2 hours? What happens if your meetings that's being transcribed last more than an hour? You have a problem. The reality today is voice agents get deployed to Kubernetes. And so if you're looking at building voice agents, something to keep in mind when you get ready to deploy them, likely your go-to solution is going to be a Kubernetes cluster, not something like a serverless function. Hopefully the state of serverless functions in the major cloud cloud platforms is going to improve as agents get more popular, but this is just the reality. If you talk to the people at LiveKit, if you talk to the people at Pipecast, they'll tell you Kubernetes is really where all of our deployments happen. So where do you get started? I think I just talked about a lot of problems, and you don't want to solve all these problems yourself. Now you could. If you have a lot of resources, you have a lot of time, and you want to build the world's greatest voice agent stack, you could go solve all these problems yourself. But you're probably going to spend a lot of time doing it. So more practically, where can you get started? Now, I'm going to talk a little bit about OpenAI. Now, obviously in China, OpenAI is not an option. But the reason I bring up OpenAI is I think that OpenAI today has the best model for voice agents. The way OpenAI's stack works is a little bit different than the way most agent stacks work. One of the nice things about OpenAI's stack for voice agents, they call it the real-time API, is that it's actually an API. It's not an agent framework. And if you look at the solutions from people like Pipecast, if you look at the solutions from people like LiveKit, which I love, the challenge with them is they're full agent frameworks. That means there's a lot of abstraction. That means that you can't always do what you want to do. The nice thing about the real-time API from OpenAI is you connect via a WebSocket or you connect via WebRTC to the session, and you just send control messages. Those messages on the client side typically are going to go over the WebRTC data channel, so you don't need a second connection. And one of the interesting things about the real-time API is it gives you a call ID. And so if you have a scenario where you want a client-side voice agent, but you need to do things like call into back-end servers securely, where the client might not have credentials to do that, you can connect the control channel on the server via WebSockets and the client channel via WebRTC. Another great thing about the OpenAI's API is that it has a great pipeline that's typically a lot lower latency than wiring it up all yourself, because it's an integrated solution, it's an integrated model. Now it does lack some support for some advanced OpenAI features, like a lot of the responses API tools, like strict tool calling. So it isn't always the best solution for building agents, but it typically is the lowest latency, and lowest latency matters to a lot of people. Now, of course, one of the big challenges with OpenAI's solution is there is a lot of lock-in. If you want to use it and you're in China, you can't. If you want to use something like the OpenAI API but use Gemini, you can't. So typically, the go-to solution right now is LiveKit. LiveKit is what actually OpenAI uses for the OpenAI advanced voice mode. LiveKit is also what Grok uses for its voice mode. So LiveKit is great. LiveKit is not specifically an agent stack. LiveKit is an open source WebRTC server. It's built on top of a project called Peon that is written in Go. You could self-host it, or you could run it in the cloud. If you're going to start building voice agents today, I would really recommend that you look at LiveKit. It's going to be the fastest way to get up and running, and it doesn't have a lot of lock-in. LiveKit has what they call the LiveKit Agents Framework. It's a Python framework. They also are working on a JavaScript port that connects over WebRTC, and it lets you get voice agents running pretty quickly. It does a lot of the stuff like the coordination between the text-to-speech provider, the speech-to-text provider, and the LLM. It supports just about any text-to-speech provider or speech-to-text provider you can find. It supports everyone's LLM, whether it's Gemini, whether it's OpenAI, whether it's a custom model running on Ollama. It doesn't matter. You can plug everything into LiveKit. And another great thing about LiveKit when it comes to Flutter is LiveKit does have client SDKs for Flutter. LiveKit has client SDKs for React Native. LiveKit has client SDKs for Swift and Android. And so you get a pretty complete agent stack out of the box, 100% open source that you can use. If you don't feel like hosting LiveKit yourself, they also have a great cloud solution. And typically what we've seen is the cost on the cloud solution is about the same or less than it costs to host it yourself anyway. So the cloud solution is pretty great. One note, LiveKit does initiate a WebSocket connection to the server. So one of the cool things about LiveKit is you don't just have access to WebRTC, but you can also use it for things like meetings between people. Things like transcription, where you might have an agent that's passive and is just transcribing behind the scenes. So now, if you don't want to use LiveKit for some reason, another great option is PipeCat. PipeCat is it's an agent framework maintained by a company called Daily. One of the nice things about PipeCat is they're very active in the open source community. Personally, while I tend to prefer using LiveKit, I do think that PipeCat has a better architecture than the LiveKit agents framework. And so if you need a lot of customization, if you need the lowest amount of lock-in possible, I think PipeCat is really a solution that you should consider. PipeCat doesn't require you to use Daily. You can actually take PipeCat and you can hook it straight to WebRTC. So some people even take PipeCat and use LiveKit with it. One note about PipeCat is that the agents must be written in Python, where in the LiveKit agents framework, you can write them in both Python and JavaScript. So PipeCat is probably the best solution if what you're trying to do is make sure you don't have any lock-in to a specific provider for your voice or video. Now, let's say you are working for a company, or you're starting your own company, and you really want to go your own. You really want to build your own stack. That's a great option, but I would really recommend, just like LiveKit, like Daily, like a ton of other companies, don't build your own WebRTC stack. Just take Peon, because you can get the entire WebRTC stack. It's Go, it's awesome. Literally everyone uses it under the covers. So this is about as low level as you want to go, and you can build your own stack on top of it. Now, opportunities. Now, the OpenAI real-time API is amazing. It's great. I think the problem, though, is that currently there's nothing open source that really maps to what OpenAI is doing. There isn't currently an open source implementation of the OpenAI real-time API. What you tend to see is a lot of open source SDKs like LiveKits and like PipeCats, which are great, but I don't think they're really the future of what we need for voice agents. What we need is something that's more like an API, that's a multimodal API, that's real-time, that you can use to talk to LLMs, and can coordinate with speech-to-text and text-to-speech providers. So if you're looking for something fun to do, and you really want to start a new project, I think this would be amazingly well received, because we really need a better model that's open source for building and deploying these real-time multimodal systems that interact with LLMs. And I really, even though LiveKit and PipeCat are great if you want to get up and running with a voice agent today, it would be really nice to have something open source and available that's more of an API and less of a framework. So one random note. Now, everything we talked about is single player. And the reality today is that voice agents are single player. That's probably not what the future looks like. Let's say, for example, you're on a Zoom call, and you would like a voice agent to be in the Zoom call, and you would like users to be able to interact with the voice agent on the Zoom call. The problem today is that voice agents can't really distinguish between intent. And so if you stick a voice agent in a Zoom call, every time anyone talks, the voice agent's going to want to respond. But people are mostly probably talking to themselves, not talking to the voice agent. if you want to build something like this, you end up in R&D territory. It's a great place to be if you like doing R&D. One of the great things to know about this scenario is that if you do want to do multiplayer voice agents, LLMs are great at detecting intent. So you can use LLMs to detect, was the person actually talking to the voice agent, or was the person talking to another user? But like I said, you are in R&D territory. So keep in mind when you're thinking about voice agent scenarios, the reality is probably today, the state of the art is a single user talking to a single agent in a quiet room. It's not a user talking, an agent talking to multiple people, and it's not an agent interacting in a noisy environment. So I think that takes us to the end. So if anyone has questions about voice agents, about agents in general, or how to go about building one of these systems, come up and talk, and I'd be happy to answer any questions you have.